were asked to determine the focal length of a convex lens. Convex lens experimentally using the no parallax method. Assume that you are provided with all items necessary to carry out this experiment. Part A. Draw a diagram to show how you would set up all the necessary items on the table to carry out this experiment and label items. Stand on which the items are mounted should be clearly drawn. There is a convex lens. We have to place the convex lens on a lens holder. Lens holder is like this. This is lens. This one is lens holder. Then we have to place object pin. Object pin. And this one is the object pin, and we have to place the screen. Screen is not using to get the equation. It is using not using to get the image. It is using as a barrier to identify image and object from surrounding objects. Then we know that when object distance is greater than focal length, we can observe an image in this side. It is a real image and inverted image. It should be formed in this direction. Therefore, we have to use an observer pin to find the image distance. This one is the observation pin. We have to use the observation pin to find the correct position of image. Image is formed in this direction. It means inverted image. Then part B. Before setting up the items for the experiment, it is convenient to know the certain data pertaining to a certain item given. What is the data? Describe the simple method to obtain an approximate value of data. First of all, we have to find the approximate focal length of the lens. Because of we can observe a real image only for object distances which are greater than focal length. Therefore, we have to know the approximate focal length. The required data is approximate focal length of lens. Then we have to write the method we can find the approximate focal length. We have to focus our image to a wall or to a board. Then we can find approximate focal length by focusing far object to the wall. Far object to the wall. It means we have to select an object which is a distant object, and we can consider parallel rays are coming from the object, and if this one is the wall, when the image is focused in wall, this distance is approximate focal length. It is not correct focal length, we can get only approximate value. Then part C. Suppose that when looking at the image after setting up all items as indicated in A, you have observed that image and observer pin are not in same vertical line. Due two reasons related to pin and other related to length. So length has two. Why this has happened? First reason, this pin, object pin or observation pin is not in the optical axis. We know that there is an optical axis for the lens like this. We have to place object pin and observation pin in the optical axis. If both pins are not in the optical axis, we can't coincide image and this observation pin. Then first one, pins are not on the optical axis. Then second one is lens. We can get lens is tilted. If the lens is tilted, we can't coincide image and this observation pin. Then part D. In this experiment, suppose you have observed that as the eye is moved sideways across the optical axis, the image moves opposite to the direction of eye movement. In this situation, state whether the observation pin should be moved towards the eye or away from the eye in order to focus the exact point of image. We can see an image formed by lens. I will consider it as this one. And this one is the observation pin. We have to move observation pin along this axis, and we have to move eyes in perpendicular direction. It should be like this. Then we can see when before coinciding these two pins, image pin and observation pin, has a relative motion. But when coinciding, both are moving without a relative motion. Now they have given when eyes are moving perpendicularly, image moves opposite to the direction of eye movement. We can do it practically by using two pens or something. Then we can get the answer. Then observation pin should be moved towards the eye. Then we can write answer for part B. Move the observation pin towards the height. You can do it using two pencils, then you can decide the moving direction. So part E. If the object distance, image distance and focal length of convex lens U, V and F respectively, rearrange the lens formula in order to determine the focal length of the lens by plotting a linear graph. State the sign convention that you have used for the lens formula. I will write the lens formula. 1 over V minus 1 over U equals 1 over F. V means image distance. Image distance is this one. Then coinciding image is formed at this place. Light rays are moving in this direction. Image distance should be in same direction. Then it is a minus sign. Minus 1 over U is the object distance. Light rays are moving in this direction. We have to get object distance opposite to the light rays. Then it is a plus value. U value is a plus value. This minus mark is this one. And for the focal length, we know that focal length of a convex lens is always minus. Now, we are changing object distance. This is the independent variable. We have to get it to the y-axis, sorry, x-axis. We are measuring V value. It is the dependent variable. We have to get it to the y-axis. It means we have to subject V term. Then I will subject the V term. We can get 1 over V. I will opposite mark of all terms. 1 over V plus 1 over U equals 1 over F. Then 1 over V equals 1 over F minus 1 over U. Then I will change positions of these two terms. I will write it directly. 1 over V equals minus 1 over U plus 1 over F. It is in the form y equals mx plus c. X-axis is 1 over U. We have to mark y-axis 1 over V. Intercept is 1 over F. Gradient is 1 minus 1. Now we have to write the sign convention. We are using new Cartesian sign convention to get marks of object distance, image distance and focal length. We have to write sign convention. There are 2 points in sign convention. First one is all distances should be measured along the optical axis from pole of lens. First one is all distances should be measured from pole and along the optical axis. Then second one is distances towards light rays are negative values. Distances opposite to light rays are positive values. Distances towards the light rays negative, opposite to light rays positive. Then part F, mark the independent variable of the equation above in E on the horizontal axis and then dependent variable on the vertical axis of given diagram. They have given x and y axis. We have to get 1 over U as the x value, 1 over V as the y value. Then part, it is part X. Then part G, draw rough sketch of the expected graph on the same diagram. Use the sign convention. Use the signs for the object distance and image distance according to the sign convention used in part E. We can draw y equals minus mx plus c type graph. Minus mx plus c type means it should be like this. We have to remember this part is for real images. This part is virtual images. And after drawing the graph, we can find the focal length. 1 over focal length is the intercept of the graph. C value is 1 over focal length, then we can find focal length by using the intercept of the graph.